All right, we have a new word for you, molar mass. Okay, so we use the like kind of italic big M that to stand for molar mass. Molar mass is the mass in grams of 1 mole. For example, a mole of carbon weighs 12.01 gram per mole. That's the molar mass, which is the mass of 1 mole of carbon, a mass of 6.02 times 10 to the third atoms. Okay. Now, the mass of 6.02 times 10 to the third atom of sodium is 22.99 grams per mole. It's atomic weight, basically. Right? And if you look at the periodic table, the 1 mole of iron atoms, or 6.02 times 10 to the third atoms of iron, with about 55.85 grams per mole. Okay, so it's just by the definition. So molar mass is the mass in grams of 1 mole. Okay, 6.02 times 10 to the third atoms or molecules. The word molar mass, formula mass, molecular weight, these are the same thing. Okay, they are the same thing, but they use it differently. I'll tell you in a bit. So formula mass is for ionic compound, and the molecular weight is for covalent compound. Right? There's a little bit different, but they all have the same meaning, which is the mass of 1 mole of atoms or molecules. Now, if you look on your blackboard, so I have posted this, right? This is the periodic table, and I hope that we use it together. If you click on that, you're going to see it here, right here. If you look at different periodic table, this number, for example, carbon right here, 12.01, could be different. It could be different by the significant figures, could be different by just slightly different by the number. So to reduce the confusion or to reduce the difference in your calculation, maybe just a little, let's use this, the same periodic table. Okay, so from now on, we're going to use this periodic table. And when you have to look up the molar mass, you're going to look into this number. Right, carbon 12.01, nitrogen 14.01, helium is 4, and hydrogen 1.01. Okay, so when you do calculation, so we will get the same number. All right, concept check. What is the formula mass of 1 mole of sodium chloride? Well, sodium chloride, so 1 mole of sodium chloride. So of course, 1 mole of sodium, which is that weight, right? And 1 mole of chlorine, which is that weight. 1 mole of sodium chloride consists of 1 mole of sodium, 1 mole of chlorine. So 1 mole of sodium weighs that, and 1 mole of chlorine, according to the periodic table, weighs just that. Basically, the 1 mole of sodium chloride, which is the molar mass of sodium plus molar mass of chlorine, right? So 22.99 plus 35.45 grams per mole. And here we go. All right. So which means that if you have a mole of sodium chloride, right, let's say you have 1 mole, exactly 1 mole of sodium chloride, which is salt. Put it on the scale, you're going to see the number 58.44 grams. Okay. All right. Calculate the mass in grams of the following. All right. So do on your own and then check with me. All right. Lithium nitrate. So 1 mole of lithium nitrate. In 1 mole of lithium nitrate, what's in it? Well, there is 1 mole of lithium, 1 mole of nitrogen, and 3 moles of oxygen. Okay, so 3 right here, right? Now look for mass for each one. So 1 mole of lithium, look at the periodic table. So 1 mole of lithium weighs 6.94 grams per mole. 1 mole of nitrogen weighs 14.01 grams, and 1 mole of oxygen 16 grams. But there are 3 of them, so that's 48 grams. Yeah. So the whole thing here, that consists of that combine into 1 mole of lithium nitrate, which is 68.95 grams. That's it. Okay. Now next one, move down to 0.5 mole of iron 2 bromide. Okay. So of course there's iron, there's bromine in it. Okay. So to make it easy for you, I'm going to calculate 1 mole, the mass of 1 mole of iron 2 bromide, and then whatever I get, I divide it by 2. Okay? All right, let's say a mole of iron 2 bromide. So 1 iron, 2 bromide. Right? So 1 mole of iron atoms and 2 moles of bromine atoms. 1 mole of iron weighs 55.85 grams. 2 moles of bromine. So 1 is 79.90. So 2, double that. All right. Combine this mass. That's the mass. This is the molar mass of iron 2 bromide, right? Per 1 mole of iron 2 bromide. The question asks for only half a mole. Divide that by 2. Here we go. Or 107.825 grams. Okay. Or you do the right number of 66. So 5 6 107.83. All right. All right. So now a little bit about the differences between molar mass and formula mass. I think you still remember the difference between covalent compound and ionic compound. The covalent compound, we use the molecular formula to represent a covalent compound, which is exactly the number of, like for example, carbon. So 1 carbon, 2 oxygen. In the molecule of carbon dioxide, actually have 1 carbon and 2 oxygen. Okay, same thing, carbon monoxide, 1 carbon, 1 oxygen, 1 carbon, 1 oxygen. So we use the molecular formula for to represent the molecules of covalent compound. That's why we have the word molecular mass or molecular weight. These are the same thing, right? The weight of 1 mole of covalent compound. Now, the ionic compound, right? We don't use the molecular mass. We don't use the molecular formula for ionic compound. You remember that ionic compound exists in what? Start with L. Lattice is good. It's not in a molecule, so it's an array of ions, right? We represent the we represent an ionic compound by using an empirical formula, which is the smallest whole number, right? In this case, so 1 barium, 1 sulfide that represent the whole thing, all right? So that's the reason why the molar mass of an ionic compound, we just call it a formula mass, which is the mass of 1 mole. But the same thing, molecular mass, molecular weight, formula mass, they're all the same thing. It's a mass of 1 mole. But we use the formula mass for ionic compound and molecular mass or molecular weight for covalent compound. Right? But we use all these terms interchangeably. Don't worry about it. They are the same thing. All right, class activity number 2, super simple there. Calculate the molecular weight of A, B, C, and D. Okay. All right, let's moving on to grams, moles, and particle.